The last topic in 7E is talking about combinations. So arrangements are all the different ways that we can arrange things with replacement, so we can repeat things. It's also an and, it's an independent, so we're multiplying. Permutations is all the different arrangements where order matters, and again we're going to multiply those. Combination is all the different arrangements where order does not matter. So in this case, my kind of reminder is ice cream bowls, because once we put the ice cream in there into a bowl, it doesn't matter what order, because we just swirled it all around. And so if we list all the combinations of A, B, C, and D, so vanilla, chocolate, strawberry, and mint, there is only one combination to do all of those, but so we don't really care when we use them all. We're only going to care about when we don't use them all. So we want 4 items, and we're going to choose 3 of them this time. And so we have vanilla, chocolate, strawberry, vanilla, chocolate, mint chocolate, vanilla, strawberry, and mint chocolate, and then chocolate, strawberry, and mint chocolate. So we just have 4 of those. And if we type this into our calculator, we would come up with the answer of 4. And so looking at our calculator, we would do 4. We go to our math key again, over to probability, and this time we're choosing C for combination. So in my case it's number 3, and then we have 3 items that we're working with. We hit enter and the answer is 4. There's always a lot more combinations than there are permutations, simply because there are, since the order doesn't matter, we can mix them all up, and so we have a lot less of the combinations. So one thing I always ask students is a combination lock correctly named? Is a combination lock truly a combination lock? Something to think about and possibly figure out in terms of whether it's truly been named correctly. Combination is one of those words that, like averages, we use to interchange things, and yet it has a specific meaning. So there are more permutations than there are combinations, just as I said. So if we're looking at just simply the combination ABC, so we had vanilla, chocolate, and strawberry. If you recall, when we had vanilla, chocolate, and strawberry, we had different ways that we can make those cones. And so we had 1, 2, 3, 4, 5, 6 cones that we could make. 3 times 2 times 1 are all the permutations, but there's just one combination that has vanilla, chocolate, and strawberry in it. Okay. So if we're picking, so examples of combinations are picking 7 people from the class to be on a committee. We don't have any specific jobs, so this is a combination. If there were specific jobs for every single one of these 7 people, then it would turn into a permutation. If we pick out 4 CDs to take on our trip from all of our collection, that is a combination, because it doesn't matter what we pick out. Now, if we decide to play them in a certain order, then that becomes a permutation. So we talked about the formula already and how to do it in the calculator. So we have 5 shirts. We select only 3, so 5C3. We don't care how we pick these out, so it's 5C3. Now, if we're going to talk about how they were worn, what order we needed to wear them, then we would change from combination to permutation. Okay. So another application of this is the lottery. There's 44 numbers for the Arizona lottery, the pick, and we have 6 numbers. And so 44 combination, doesn't matter what order we get those numbers as long as we get them. So we have 7 million different ways to arrange these 44 numbers in a winning lottery ticket, and therefore the probability is 1 out of 7 million. So many times we talk about that we're gonna, as the value of the lottery increases, everybody goes and buys more tickets. So if we buy more than 1 ticket, when playing the lottery, does the probability increase, decrease, stay the same? Does the odds increase, decrease, or stay the same? And it's, do the expected value increase, decrease, or stay the same? Or do none of these change at all? Or do they all change, and how do they change? So this will be a question to think about. It will be a final exam question. So think about it, and perhaps we'll come up with an answer. Think in terms of what each one of these means, and then if I buy more tickets, are any of these or are all of these influenced by it? So if we look at the Powerball and the Mega Millions, so should we spend our $2 playing the Powerball, or should we spend $2 playing the Mega Millions? If, let's suppose that, we could do the expected value, depending on what day it is in terms of the amount of money, but just in terms of the probability, which ones would be better. So if the probability for the Powerball, so we're going to pick 5 white ones. So for the Powerball, we have 5 white ones, and there's a total of 59 to choose from. And we have 5 of them, and 1 red one. So we need to get that one in there too. So the combination of that is we have 39 of those, and we get 1 of those. And again, it doesn't matter how we do that one. So if we type that into our calculator, we have 59, math, go into probability, and then we want number 3 for combinations, 5, and I'm going to just hit enter here to find out what that number is. And then I'm going to do the same thing, so I'm going to do 39, and then math, and probability, and number 3 for combinations, 1. And you know that there's 39 ways to pick 39 balls. So now I'm going to multiply these two numbers together. So I'm going to just take that and multiply by this big number right here, and we end up with 1952, 49, 054. So that means the probability is of the Powerball is 1 out of 195 to 490, 54. Let's put in some commas here. 195 million, 1 in 195 million possible chances there. And so Mega Millions, we would do a similar way, and you can figure out what that probability is, and then decide, is it better to do the Powerball, or is it better to do the Mega Millions? Spend your $2, which one has the better probability?